Welcome to AI through the eye of Epoch. 4 years ago, 3 students had a vision. Although AI was not as intelligent as it is today, these students recognized its potential. Team Epoch became the first place on campus where students put AI theory into practice. Epoch started competing in international competitions. With increased knowledge and a growing base of alumni, the next step was to showcase AI's potential for positive impact. Every challenge, every competition, and every project contributes to the United Nations Sustainable Development Goals. Extreme skills, knowledge, and dedication meet Epoch 4. A team of 15 multidisciplinary students, each with their own expertise. A team of leaders, AI engineers, and creative thinkers. What sets us apart is the way we think. AI is here. It is what you use it for that will make a difference. By competing, we will show that AI can be implemented for good causes, turning possibilities into reality. This year, we will show the world the potential of AI. Our goal for this year is to become the best performing AI student team worldwide, beating world-class universities such as Stanford, Harvard, and MIT.
Team Epoch is unlocking the potential of AI, and you are invited to be part of it.
Our AIs will contribute to the healthcare sector, governmental institutions, and nature conservation.
Get ready for our next move. What role does artificial intelligence, AI, have in our future? Does it have a role in the future we want? We believe there's a place for AI, and more importantly, we believe that there's a way to implement it sustainably to the benefit of all. My name is Robert van Poeteren, and together with my team, Team Epoch, we take steps to realize this vision by developing this technology here in Delft. I stand before you at an exciting time. The landscape of AI is taking shape, transforming everything. But how much exactly? I invite you all to stand up. Let's see how much you all use AI. Please sit down if you've used Google Maps to get here this evening. Please sit down if you've used ChatGPT today. And finally, please sit down if you use any kind of social media today. Okay, thank you all for participating. You can all sit down now. But I noticed that almost everyone is already sitting. The reason why I ask these questions is to show you how much we already use AI. We all use it, not just the ones that came here in their self-driving Tesla. With the world changing so much around us, a place to delve into the development of AI became essential. While faculties are slowly introducing AI into their curriculum, focusing a full year on learning and sharing knowledge on AI becomes essential. This allows students to dedicate themselves fully to the development. Instead of focusing on theory and making it just work, you focus on performance and optimization. This is the distinction between science and engineering. We've created a place for innovation in Delft, where you can create the AI of tomorrow. While developing AI is not as straightforward that every line of code will do something that's beneficial to humanity. That's why we as individuals and as a team feel the responsibility to make the right decisions in what to develop. AI gets applied everywhere, where it's technically and commercially viable. Yet we don't know if that's the role we want AI to take on. Because of our partners, we at Epoch have the freedom to make non-commercial decisions. Instead, we choose to focus on the impact of our work. A lot of applications do not get the attention they deserve. While implementation can be straightforward, the benefits to humanity obvious, and there's no commercial reason companies simply can't focus on them. That's where we come in. Those are the projects we put our attention on. Our compass is set by the United Nations Sustainable Development Goals, a blueprint for addressing global challenges, whether it's mitigating climate change, helping education. They are designed to help positively to humanity. We also choose multiple competitions. We do this because we can reach as many people as possible in this way. In line with this philosophy, we make all our code open source. This means that everyone, everywhere, at any time can use our code, no strings attached. Where possible, we not only publish, but seek out people who could benefit from this code. One of the defining traits of Epoch is its competitiveness. Since Epoch 1, we have participated in competitions. And since Epoch 1, it has been a dream of ours to win. It gives us something to measure. While you would look at a stopwatch to see how well a racing team is doing, we look at accuracy. How well does this block of code predict the real world? It's a source of motivation and the perfect place to see how much you've learned. It is important to also shine light on how these ideas actually get put into practice. Because AI can do a lot, but to make it work, you have to put in the work. We started this year with 7, and we have now more than doubled to 15 people. We are different in the way we work with AI. Some focus on code, others focus on implementation. But we have together one goal, to make AI, the development of AI, in a positive way. Our team consists of 6 different disciplines. It's not just computer science. It's clear that in your studies you learn a certain way of thinking. And this is the reason why a multidisciplinary team, a team of multiple studies, can generate so many different ideas. This advantage cannot be understated. I think it's the reason why we have been able to participate against PhDers and departments of companies. I noticed that these different fields and different studies also complement each other. Sometimes we have a masterclass from the engineers on how AI works. And the things that they explain, which they would find hard, like general concepts, are easy to understand, while the things that may seem obvious are where most explanation is needed. Not everyone had cross-validation or non-linear program in their courses. It goes the other way as well. Sometimes operations gives a masterclass on how to negotiate with partners, and it could be one of the most useful things learned this year. The last factor I want to highlight is the support we get. Having alumni to count on and having partners to work with is a reason why I can stand here before you today. A special thanks to you. Tonight, let's approach AI not as magic, but as a grounded innovation. Welcome to AI through the eye of Epoch. One of the hardest things when working with AI is explaining to people what exactly it is what you're doing. So our chief engineer will start with a short explanation on the basics of AI, so we're all up to speed. With the basics covered, we dive in deeper, showing what we have learned and what we did this year. When you do multiple competitions, the things that repeat we notice those things. We, for example, always start with a baseline. It's like a prototype, a proof that our setup works. This is a place for improvement. We have developed a tool to make this multiple-week process of developing this baseline work with a few lines of code. This enables us to work on the logic behind the program much sooner, making it possible to also make advanced programs. In our first competition, it took us 4 weeks to make this first working prototype. In our latest, most recent one, we jumped from place 500 to place 10 in just 4 weeks, in 4 days, with the use of this tool. It's an adaptable framework, and it's based on all the knowledge of our previous competitions. It will continue to help us with the development of all future models. This tool will later be revealed. After this, we'll talk about the achievements that we have gotten here this year. How we have developed AIs that play a supportive role within the healthcare sector, focusing on reliability and therefore gaining trust. How we have pioneered implementing AI into the Dutch government, making it possible for citizens and press to access governmental documents. And finally, we'll talk about our ocean life competition, where we had to identify kelp, a kind of underwater plant. With the use of satellite imagery, we had to see where this kelp was around the globe. And we won this competition, beating 670 participants. But I'm getting ahead of myself. First, let's talk about the basics of AI. I'm honored to welcome our chief engineer, Emiel Witting, to the stage.
Thank you, Robert, and good evening, everyone. Tonight, I would like to take you along into our world for a moment, a world of self-learning machines. In this chapter of the presentation, we'll offer a look inside the black box of AI and present what we've been working on over the past year. But first, let's start with the foundation. What even is AI, this thing that is being mentioned so often now? It is a technique inspired by nature that allows machines to learn any complex task, including those that normally only people can do. The type of AI that we see most is called supervised learning. What this means is that we have labeled data. These are examples of input and correct output. So these can be, for instance, images of pets, labeled to whether it is a cat or a dog in the image. If you had enough of these examples, it will become possible to train an AI to recognize which animal is in an image that it has never seen before. So let's see what the training looks like. We always start with some form of data. This can be an image, but it can also be audio, or video, or text, or simply some numbers. This is then fed through a so-called neural network to produce a result. But this result might not immediately be correct. So what we then do is we compare it against the actual result, against the label. By measuring exactly what these differences are, so by measuring where the AI is making mistakes, we can improve it so that it can do a little bit better each time. Let's dive into this neural network, where everything happens. Imagine rows upon rows of neurons, much like those in our own brain, each row connected to the next. When data triggers the first layer of neurons, it sets off a chain reaction throughout the network, producing a result at the other end. Now, which exact pattern forms depends on how the network is connected, how strong these links are. So, if you want to improve it, if there's a mistake in the result, we need to change the strength of these edges. And a chain reaction happens in the other direction. From back to front, the strengths of all links are changed. So that's what it means to train an AI. Connect the network so that it produces the responses we want. If you repeat that for every example in your dataset, then you've completed one iteration, or as we call it in AI, one epoch. So, why would you use this? Well, there are multiple reasons, but one of the most important ones is time efficiency. A system like this on a modern computer can process enormous amounts of information, or create enormous amounts of information in an instant. Second is availability. For example, an AI system can monitor a patient in a hospital while the doctor is taking a break or away from their shift. And lastly, large-scale application. If people across the world are sharing the same problem, then a single digital solution can help all of them at the same time. There are also some things we need to consider, or some things we need to take care of as responsible AI developers. First is liability. we make sure that in high-risk situations, there is always a human in the loop. This means that a person is making the final decision, and also that a person is end responsible for this final decision. For lower-risk situations, we still want to ensure reliability. What this means is that we optimize and test our models to ensure that they perform at an accuracy that is acceptable, which often means that they make even less mistakes than people do. So that is the foundation of AI. Now it's time to look at a real-world problem that it can solve. Giant kelp is one of the fastest growing organisms on Earth. It is vital for ecosystems, not only because it serves as food and shelter for sea life, but also because it is able to capture nearly 5 million tons of CO2 every year. Unfortunately, though, kelp forests are on a steep decline. This is caused by climate change and overfishing. And monitoring this decline is difficult. It would require manual work from scuba divers and intensive labor. That is why satellite images are a solution. Combining those with AI, we made it possible to track the health of kelp forests across the world all at the same time. Let's see how we did this. We were using the same principles as before, supervised learning. We start with data, this time satellite imagery, consisting of photographs of shorelines, but also infrared, because infrared light is able to see through water much better. Then this goes through a neural network called a UNet. This is similar like before, but this time the layers have the shape of images. This will produce a result, which will be an estimate of where the kelp is growing. Now, like before, this result might be wrong at first, so we'll have to compare it against the actual result, using handmade maps of where the kelp is growing in real life. By seeing exactly how the model is making different predictions, we can then improve it, so that the next time, at least for this image, it will be better. And if we repeat that for all the images we have, then we have our final solution. So that is the core of our solution, but it's definitely not all we had to do to become first in a worldwide challenge. We applied optimizations across the solution, and I would like to give a few examples. The first thing that we do is increase the amount of data we have. Since AI learns from examples, if you have more examples, it learns better. We do this by combining and transforming the images that we have. And by doing this in multiple ways, we can generate so many images that it will be the same amount as every water molecule on Earth in all the oceans. Then we help the model a bit. From these images, we can emphasize the important information. For instance, we know that kelp grows more closely to coastlines. So we make maps for every point on the map, how close it is to the coast. And we give this to the network. But it is important to mention that this is not new information. We make these maps from the photograph that it already gets. But still, it guides the model in the right direction and lets the AI learn faster. And this, coming up with these kinds of maps, that's where human creativity and domain expertise play a large role in developing AIs. Now, the last thing I want to mention is that there is never a single solution that works for everything. Everything is advantages and disadvantages. So what we do is we look for multiple solutions that complement each other. For example, here you can see 3 different AI models that all are able to locate a different patch of kelp. What we can then do is combine these. We add all of them together to give a more balanced estimate of where the kelp is growing. And this gives our final map of kelp and also our final boost in performance. So, now you've seen that we can use AI to map kelp forests. But we also use it for sleep research or for the search for new medicine. The same tool for different problems. Each time the process is similar, so how do we do that efficiently? You might say, make one good solution and adapt it. Change it each time. Now this might work, but it will not work at top performance. It will not be specialized enough. And with that reasoning, you might say that starting over each time is necessary to perform at the level of a dream team. But you also don't want to waste valuable time repeating the same tasks at the start of every project. So we still needed another solution. And that is why we developed a modular framework for high-performance AI, which we call E4. We've used what we learned throughout the year to find a perfect balance between something that is reusable, so it saves time, but is also flexible to make it possible to go into any direction. It consists of 3 parts. First, a framework, something that is general enough to work with any state-of-the-art AI method. Then a collection of modules that fit into this framework. These can be specialized, but you would only use the ones that are relevant for the current project. And this is a library that will get more useful as it grows over time, and we make more of these building blocks for future projects. And then lastly, an application. This is a filled-in framework with the most common modules, and this serves as a starting point for new projects. This is what made it possible for us to go from something taking 4 weeks to only a single line of code. Now, this will not only be useful for future competitions of Epoch. It will also make it possible to more easily adapt our competition code into practical applications. And as always, we make our code open source, so it is publicly available. And this is, in the long term, how Epoch 4 contributes to positive development of AI. But that is long term. And we've shown that in the short term, during this year, we've already been able to make an impact. And to let you know more about that, I would like to invite Suusje Helwegen on stage. Thank you.
How do you go from creation to implementation? And how do you go from an idea to impact? These are questions that we ask ourselves in everything we do. And this starts from the moment we choose a competition. We actively choose a competition that we feel connected to. Is it pushing boundaries in the right way? Is the area in need of an AI? And will it result in a positive impact? When I joined Epoch at the beginning of this year, answering these questions felt almost impossible to do. And I confess, I don't know how to make an AI. But during these months, I learned that AI does not only need the smartest computer scientists. It needs all of us. It needs policymakers, creative thinkers, safety and privacy experts, ethicists. I could go on all night. My point is that AI is here, and AI will stay here. It will become a bigger part of everyone's lives. But that doesn't mean it will take over your life, as long as you stay involved. On to our approach. How do we go from an idea to impact? We started our year off with a competition about sleep, hosted by the Child Mind Institute. This was an area that none of us had any real knowledge of yet, apart from the fact that maybe we knew we didn't get enough of it. But the more we dove into the topic, the more we understood the problem at hand. How do we improve the labor-intensive sleep studies for children with AI? And this competition opened the door for us to go from creation to implementation. It made us dream bigger and beyond our thoughts of just making groundbreaking AI models, but that we could actually make real impact. Because what if our AI could actually be used in a hospital? And that is when we met Joyce. She's a doctor that specializes in sleep studies for children. And with her enthusiasm and curiosity, we're making it happen. Together with her and researchers from the TU Eindhoven, we're creating a package that can help somnologists in treating their patients. Our AI model tracks a child's sleep with the help of actographs, a type of watch that can track your movement. And based on this data, you can classify whether someone is in a wake state or in a sleep state. And initially, this data had to be analyzed by Joyce herself. But with the help of our AI model, we can help her save a lot of time. And this was the first competition that introduced us to the use of AI in the healthcare sector, an area in which the interaction between humans is very important. And this may result in the fact that you might fear the introduction of these technologies. Because can an AI provide me with the same care as a human being? We believe that AI can play a great supportive role in this sector, just like our AI model does for Joyce in treating her patients. And this is what we also saw in our competition about classifying harmful brain activity, hosted by the Harvard Medical Institute. Again, a competition with a complex problem statement. And to understand this, we spoke with multiple neurologists who could tell us that most of their work relies on analyzing brain activity data from EEGs. And based on this, they can search for abnormalities in the functioning of the brain, like epilepsy or seizures. For this competition, we received a dataset with the same information, for which we had to create an AI model that could classify harmful brain activity, so that neurologists can be alerted when the model classifies that something is wrong. And through both these competitions, we found that it is important to create AI models that show expert-level accuracy, or even outperform experts. Through providing this reliability, our AI models can gain trust for use in settings like the healthcare sector. Onto a project that is a bit closer to home is our project with the Dutch government and National Archive. In 2022, the Dutch government introduced the Wet Open Overheid to improve transparency in governance. Access to information is a fundamental human right, but in practice, it's complex. The National Archive is the biggest archive institute of the country, and their database consists of around 150 kilometers of printed and handwritten documents, 300,000 drawings and maps, and 15 million pictures. Information requests are most often made by journalists or citizens who want to gain information on a certain topic. This request has to be answered within 42 days, but sometimes this deadline gets surpassed. The issue is that it is difficult to create a structured system, causing delays in processing information requests. Our solution: an AI model that organizes archive documents based on time and context, making them easily accessible. And by providing this clarity, we're helping the Dutch government disclose information more efficiently, improving transparency, and paving the way for further progress. And now, on to maybe one of our most significant milestones of this year, was our Kelp competition. We started the year with the idea, let's win from other students and other student teams out there. That would be cool, right? But what if we could win from 670 senior AI engineers, satellite experts, professors, researchers? That would be a dream, right? Well, I'm proud to say that we did it. We beat 670 participants and became number one. With the knowledge of our previous achievements, we had a swift takeoff. The problem statement of this competition was clear and allowed us to emerge in the research world of giant kelp forests. And to understand the urgency for research in this field, we spoke with the Kelp Forest Foundation. And through them, we came into contact with Michael Matthews, a researcher from NewMedia, who experiences firsthand what it is like to see these forests depleting through the effects of climate change.
Hello everyone, my name is Michael Matthews. I'm Master of Science in Fisheries and Aquatic Sciences studied at the University of NewMedia. I am doing my research with Kelp NewMedia, and my studies are fully funded by the Kelp Forest Foundation. So this process, when you do it manually, it usually takes time because we have to download the large files of satellite data from either Landsat or Sentinel. And currently, with AI, everything is made easier and very efficient because these algorithms can be trained to do it automatically, and they are quite accurate, and they can come up with various predictive models, which are very important when it comes to presenting this satellite data. I just want to congratulate the Epoch team for winning the competition. Thank you.
I'm proud to say that our winning AI model, which we worked on for 3 months, is now being used to revolutionize our understanding of marine ecosystems, not only by the competition host, but also in Namibia, and hopefully in the future worldwide. Through all of our work this year, we found that progress thrives when you are connected. Once you step outside of your comfort zone and have conversations with the people affected by our models, a lot of opportunities arise. Involving ourselves in fields that we are not familiar with gave us endless possibilities and ideas. Connecting the people behind AI with the people affected by AI is crucial. That is why we would like to introduce you to our Artificial Intelligence Hub, an open community to share knowledge, ask questions, and talk about the present and future of AI. What is needed is the possibility to have conversations about AI in different contexts, with people from different backgrounds, experts from different fields, and anyone who is impacted by these technologies. We believe that only through these open spaces, the promise of AI can be fulfilled. So, when this presentation is over, we would like you to join us in the Frans van Hasseltzaal, where we have some drinks and snacks. But you can also experience for the first time our understanding of an AI hub. And on the tables, you will find questions and conversation starters, which we would like you to use. And who knows what it will set in motion. AI won't wait for us. So join the conversation now. And I think it is now time to welcome the rest of our team on stage.
Thank you, Suusje and Emil. While everyone is gathering on stage, let me tell you what's in store for us these last 2 months. We're still busy with 2 competitions, and we have 1 big event planned, a debate. If this all sounded interesting to you, there's still a chance you can join Epoch for next year. Please come up to us during the drinks. Okay. I think we're all here. I want to say a few words to the team as well. To have such a team is very special. To have always something happening in the office, to set aside studies and to work on such a special project is very special. I think we had a blazing start, and we have continued that momentum up until this point. To have our biggest goal of winning competition already achieved after the second one is amazing. I know it reflects the way in which way we have worked, and especially how hard. I couldn't be happier with how everything went. Thank you. I want to thank friends and family for making it possible for us to make this commitment. I want to thank our partners for the funds and technical knowledge, a very big contribution. And I want to thank the experience for the ones before us, from Epoch 1, 2, and 3. Without it, it couldn't be possible. And finally, I want to thank you all for coming here this evening. I see you in the drinks.